Hello everyone, my name is Preeti. My presentation topic name is Instrumentation of Atomic Emission Spectroscopy. First of all, define the spectroscopy. The spectroscopy is the interaction of matter and the electromagnetic radiations. Then the defined atomic emission spectroscopy. It is atomic emission spectroscopy is also analytical technique that is used to measure the concentration of element in the sample. Then the technique is also known as optical emission spectroscopy. It is also the quantitative analysis for ppm to level to percentage level. It is used the qualitative measurement of emission from excited atom to determine the analyte concentration. Then it is also used to determine the metals, metalloids and non-metals. This is the introduction of the atomic emission spectroscopy. Then the instrumentation of atomic emission spectroscopy. First, there are various types of atomic emission instrumentations. First is a source and sample. Second is a atomizer. Third is a monochromator. Fourth is a detector and readout device. First, the schematic diagrams for atomic emission spectrometer. First is the excited atom. See in this diagram, excitation source, lens, wavelength sectors and detector. Then the first of all the light source. The light source, there are four types. First is the inductive coupled plasma. Second is a direct current plasma, flame and arc and spark. First is the inductive coupled plasma. First, then the defined plasma. Plasma is generated device called as torque. Then the orgone inductive coupled plasma consists of three concentric silica quartz tubes. See in this diagram. Then the orgone cooler tube is defined the plasma shape. Then the argon stream that carries the sample in the form of aerosols then pass through the central tubes. The plasma is initiated by the spark from Tesla coil. The argon is gas ionized and then the emission is measured. See in this diagram, plasma tube, coolant tube. That's the coolant tube is outer tube defined plasma shape. Okay. Then second is a flame. Flame is the consist of total consumption burner, which is sample is drawn through the capillary tube, which injected directly into the flame, and the flame is high temperature source that is used to dissolve it and generate the free atom from spectroscopic studies. Third is the arc sources. It also consists of primary circuit voltage is 110 to 220 volt is maintained. Then the high voltage is obtained from the transformer, which is convert the line power to 15,000 to 40,000 volt, which charge the capacitor. Then energy also stored in the capacitors, synchronous trigger, the spark between electrodes. Then see in this diagram the transformer, synchronous gap, spark gap, spray gaps, and the transformer setup is 10,000 to 40,000 volt. See in this diagram. Then the atomizer. The element can be analyzed need to in atomic state. The atomization that is defined conversion of sample solid and liquid into the free gaseous atom. Atomizer device used for atomization. There are two types of atomizers. First is the flame atomizer and electrothermal atomizer. First, the flame atomizer. The flame atomizer is produce the flame required oxidant gas and flame gas. Second is the air acetylene flame and nitrous oxide acetylene flame also used in the flame atomizer. Liquid sample are used with flame atomizer. There are flame atomizer are two types of. First is the continuous and second is a discrete. First is the continuous atomizer. The sample is penetrate the atomizer at constant speed, but they have not used for the dissolved solid. Then second is a discrete atomizer. A discrete atomizer measure amount of sample enter in the atomizer. Then it is effective when sample is required. Second is the electrothermal atomizer. Electrothermal atomizer is also known as graphite furnace atomizer. Convenient, they are used for non-flame method, that is electrically heated graphite tube. They serve as sample. Then monochromator. The monochromator is a device that used to transmit a narrow band of wavelength which shows the wavelength wide range is available. There are two types of monochromator. First is a prism monochromator. Second is a diffraction grating monochromator. First is a prism monochromator. Prism. The light is passed through the through its emerge out in the form of two lines or beam. The prism material depend on the wavelength. Shorter wavelength is more refracted than the longer wavelength. When light is passed through the prism, it split into two beams. Second half prism combine two beam into the single beam. Then diffraction grating. It gives the better result and resolution. Problem occur during the identification of wavelength of emission line on photographic plate solved through the grating monochromator. Then once we identify the known reference line and the other lines identify automatically. Then detector. There are two types. First is a photomultiplier tube. Second is photographic plate. The photomultiplier tube, the vacuum phototube are extremely selective detector of light in the ultraviolet, visible, near infrared region of electromagnetic spectrum. The photographic plate, the quantitative analysis of photographic plate is used on which all the emission lines from sample are recorded. The photographic recording is also called spectrograph, and one using the photoelectric device as a spectrophotometer. And then they give the readout device, detect the readout device, reading also detect the readout device. And then see this diagram, the photomultiplier tube, diodes, anodes, then primary electrodes, secondary electrodes, photocathodes, focusing electrons, see in this diagram. Then thank you friend.